what is a perfect square trinomial? It's going to look like this. It's either a squared plus 2ab plus b squared. That's one form. So that's one trinomial it could be. Or a squared minus 2ab plus b squared. Yeah, Jackson.
Does that mean that terms A and C have to be squared?
Exactly. So this first term and the first and last terms have to be perfect squares because it's a squared or b squared. So for instance, 8 squared is 8 times 8, which is 64. So you're going to see things here in the first and the last spot that are perfect squares. The middle is double of those things multiplied together. That's basically what we have. And when we see things like this, our shortcut, so I'll do that in blue. The shortcut for the first one, since they're perfect squares, it's going to be 2 of these, so a plus b squared. If you multiply that out, you get that. The other one would be a minus b squared. Notice how if there's a plus sign in the middle, it's going to be plus. If there's a minus sign in the middle, it's going to be subtraction. So if you take a binomial and you square it, you get this. And that's why you end up getting perfect squares. So we got a bunch of perfect square trinomials here. Well, I guess not a bunch. We got 3. And we're going to factor those. Again, you should notice with me that the first and the last terms are perfect squares. What number is in front of h squared right now? 1. Okay, is 1 a perfect square? Yep, 1 times 1. Is 16 a perfect square? Yes, 4 times 4. So since the first and last terms are perfect squares, in the middle is double of 1 times 4. You can factor as a perfect square trinomial. So it's going to be h plus 4. So the square root of the first term, the square root of the last term, squared. If you want, you could put 1h, but you don't need to. So this is a perfect square. You square it out, you get that. That's a shortcut. Okay, next one. And if you wanted to factor this normally, you can. A is 1, so 2 numbers that multiply to 16 and add to 8 are 4 and 4. So this is the same thing as h plus 4 times h plus 4. You could factor it the normal way and you'll get the same thing. Yeah?
What did you do to the 8h?
What did I do to it?
Yeah. Like I did just 8 plus 4.
Yeah, so what I've done is I've factored it into these two pieces, right? 4 times 4 multiply to 16 and add to 8.
Oh, it's like the x.
Yeah, so the same thing. And instead of writing it as 2 separate parentheses, we write it as 1 with a squared. Next one. The number in front of m squared right now is a 1. So is 1 a perfect square? Is 81 a perfect square? Yes, 9 times 9. So we split it up. We do this. Square root of the first term is m, because m squared, there are 2 of those. M times m gives me n squared. What's the square root of 81? 9. So m plus 9 squared. There would be 2 of those. It would just be m plus 9 times m plus 9. Because 2 numbers that multiply to 81 and add to 18 are 9 and 9. And then the last one, okay, don't get freaked out by the number in the middle. Is 64 a perfect square? Yes. Is 49? Yay! So you don't have to factor this. By doing all the work, you know that the square root of 64 is 8, so you'll put 8x. What's the square root of 49? 7. So 8x plus 7, there will be 2 of those multiplied together. Again, just so you understand, this is the same thing as having 8x plus 7 times 8x plus 7. You would get the exact same thing as if you factored it like we did the last several days. So if you don't recognize that it's perfect squares, that's okay. Okay, I'm going to give you just a couple more examples here because there's not some on the front. So can you write these down kind of right below it? So another example for you, if it was h squared minus 8h plus 16, it's largely going to be the same. So it's a binomial squared. It'll still be h and 4, but what's going to be different? Negative sign. So h minus 4 squared, because two numbers that multiply to positive 16 add to negative 8 are negative 4 and negative 4. Okay. Can you do the next one for me? So just like this one, so m squared minus 18m plus 81, what would that be if you factored it? Jacqueline, what would it have to be? Yep. Minus 9. So that's the only difference. You'd have to have two negatives to multiply to get to that positive number and add to the middle. Okay, moving on. Now the next one is difference of two squares. So that's first shortcut. Here's the second. If it's a difference of two squares, it looks like this. It's going to be a squared minus b squared. And when we factor that, it factors into a plus b and a minus b. We've actually done some like this already. So the b term is 0, but you have two perfect squares. Okay. First example is w squared minus 144. What number is in front of w squared? 1. Is 1 a perfect square? Is 144 a perfect square? Yep, 12 times 12. So we can write this as w plus 12 times w minus 12. Here's why this works. This is the same thing as w squared plus 0w minus 144. So two numbers that multiply to negative 144 are those two, and they also add to 0. That's why it works. So because your b term is 0, you need two numbers to multiply it, you'll have the positive and the negative. But those are the ones that I want you to get quickly. Okay, moving on. T squared minus 25. Is 25 a perfect square? Brilliant. Two numbers that multiply to negative 25 and add to 0 are what? Multiply to negative 25 and add to 0. What would it be? Positive 5 and negative 5. There we go. Done. You can recognize that it's a difference of perfect squares. That's good. And you can always check your work by multiplying it out. Is 4 a perfect square? Yep, it's 49. Yes, so since they're both perfect squares, you're going to take their square roots. So it'll be 2p plus 7 and 2p minus 7. Cool. Yes?
You only write it twice. You didn't, like,
Correct, yeah. So since those parentheses are not the same, you can have to write them separately. Okay, those are the only shortcuts, so now we're just going to practice. The next one's on the back. You need to find the GCF first. So the GCF between 24g squared and negative 6. What can those both divide by, guys? 6. Take it out. So 6 times the quantity 4g squared minus 1. Look at what you have now. Is 4 a perfect square? Is 1 a perfect square? Is there a minus sign in between? Then difference of perfect squares. So it'd be 6 times 2g plus 1. And the other one would be 2g minus 1. Can you please try the next two? So go for it, please, with your partner. Make sure you take out the GCF first. Well, that'd be 12. Make sure you take out the actual GCF for the second one. It is not 6, it is 12. The second one, you also get difference of perfect squares. So you could split it up into t minus 2 and t plus 2 with a 12 out in front.
So would it be t plus 4 and t minus 4?
What's a square root of 4?
2.
2, so it'd be t minus 2. T plus 2. Okay, and then the last one, you can factor a GCF of 3. So it'd be 3 times 4x squared plus 4x plus 1. This is a perfect square trinomial like we saw on the front. So that is, so two numbers, oh, not going to do it like that. So it would have to be 2x plus 1 squared. Because 4 is a perfect square and so is 1. Okay, just a couple more. Next question asks you, the given expression represents the area. Find the side length. So to get area, we do the length times the width. On a square, what do we know to be true about the length and width? Same. So I need two of the same things multiplied together. So we need to factor this. Is 100 a perfect square? Is 121? So yay, that makes it easier for you. So the square root of 100 is 10, so 10r. What's the square root of 121? 11. This is a perfect square trinomial, but since there's a minus sign in the middle, you need to have minus 11 squared. So the length is one of those, 10r minus 11. Okay, there are 6 more. Can you please try those with your partner? They're all special cases. So Try the 6 to the bottom. But just make sure you put parentheses around it. So this is a difference in perfect squares, like we had on these and like here. Okay? So it's going to be 1 plus, it's going to be plus something and minus something.